Hey, welcome back, students. In this video we want to go ahead and look at another sample problem, and in this problem we're going to be given some information including the percent yield to start and a starting amount of a reactant, and we need to figure out how much of a product is actually going to be produced. Okay, so what we got to do is first begin by creating our grid, and so let's go ahead and do that now. So we're going to go ahead and draw some lines and then some columns here wherever we see a plus sign and arrow. And so we'll do that several times here, and one more. And so what I'm going to do is I'm going to go ahead and clean this up a bit so I can write at the bottom and create this over here, so then I can create my rows. And so this is going to be the section for grams, my molar mass, which I'm just going to write as mm, and then mol for the number of moles. And so all I have to do at this point is just transfer information that I currently have. Keep in mind that the original equation for percent yield is up at the top. So percent yield is equal to the actual divided by the expected times 100. So what I want to do is go ahead and identify some of the information that I have. I have 32 grams of oxygen gas, and I also have a percent yield of 64.7%. So if I look at this equation, let me go ahead and write it down here. So instead of having a percent y, and actually let me change colors. So instead of having a percent y to begin with is equal to A divided by E times 100, what we're going to do is we're just going to substitute this information that we already have. We're going to take the percent y out and we're going to replace it with what they provide us, and they provide us the number already, 64.7%. Okay? And so what we need to do at this point is we need to figure out what our actual is going to be and what our expected is going to be. So if they give us a starting amount of 32 grams of oxygen gas, we just need to figure out what is the amount that we expect to get if we start with 32 grams of oxygen gas. So the very first or the very next step that we're going to do is we're going to have to figure out what is the expected. Okay, and so that's what we're looking for next. And from that we can figure out what the actual is going to be based on this percent yield. And so what we'll do here is we'll transfer the 32 grams of oxygen into the appropriate column. And so that goes here, 32.0 grams of oxygen. The molar mass for oxygen, just going down here, is going to be 32 grams per mole. And if I take this 32.0 grams divided by 32 grams per mole, obviously what we're going to get here is 1 mole of oxygen is going to be used, or 32 grams is equal to 1 mole of oxygen. And since what we're trying to find here is going to be how many grams of carbon dioxide, the actual column that we're looking for here is we need to figure out this value here for X. We need to figure out the value of Y because that's the molar mass, and then that's going to lead us to the value up here for the carbon dioxide, which is going to be our expected. Okay? So we'll just put that as an E. And so what we'll do here is we'll go ahead and figure out how many moles. And in this particular case, since we have 1 mole, we're going to multiply that times 3 divided by 5, and that should give us the number there that we want for the carbon dioxide. If we go ahead and do that math there, essentially what we're going to do is we're going to take that number again, 1 times 3 divided by 5. And that should give us a value of 0.6 moles for the carbon dioxide. And if we look at the molar mass for carbon dioxide, we know that we're going to have a mass of 16 grams for the oxygen times 2, and we're going to add the mass of 1 carbon, which is 12. And that gives us a mass of 44.01, depending on whether you round it or not. In this case, I did not, so I'm just going to leave it as 44 grams per mole. And now I've got my Y value and my X value corresponding to the number of moles for X, and Y corresponding to the molar mass of carbon dioxide. If I multiply these two numbers together, that should give me the following. It should give me an expected value in grams of 26.4. Okay? And so that's what we expect. So now I can come down here to the bottom of the equation and replace it with the 26.4. Okay? And so all I need to do now is solve for X. And so let me just go ahead and do that for us now. So what I'm going to do is I'm going to go ahead In this particular case, I'm going to divide by 100, and essentially that's going to cancel on that side. I'm going to go ahead and divide by 100 here, and let's just get rid of the 100 on the right side. And so this cancels, it goes away, and I'm going to be left with this. Whenever we divide a percent by 100, essentially what we're doing is we're going to be moving the decimal point 2 spaces to the left. So this 64.7 actually gets turned into 0.647. So let me rewrite that as 0.647. This is equal to a divided by 26.4. If I want to get a by itself, divide or multiply by 26.4. That's going to cancel the 26.4s on the right. And if I do that, I need to multiply this by 26.4 on the left-hand side. And that should give me the a value. So let me just erase what happens on the right side. The 26.4 goes away, and what I have here is my value a, and that's what I'm going to find now. And I'm just going to go ahead and rewrite that there as an a. And so if I take that 26.4 and I multiply it by 0.647, what I expect to get, or the actual amount that I should get, if I have a percent yield of 64.7, I should get an actual amount of 17.1 grams of CO2 produced. Okay, and that's my answer there. So that's the way you kind of use it if you have a slightly different problem. If they give you the percent yield and you're asked to figure out how much do you actually produce if the yield is this amount. That's the way you actually solve the problem there. So if you have any questions, go ahead and ask us in class. If not, subscribe us, and we will see you soon.